Hi there. In this video, we are going to talk about how to solve linear equations. And we'll look at an example where we use the methods we learn here to convert temperatures from Fahrenheit into Celsius. So here we have an equation. An equation is a pair of expressions separated by an equals sign. So equals gives us equation. Now, in this case, the expressions are linear. That means that the largest exponent that you'll find on the variable is a 1. And when it's a 1, we don't write it. We just leave it blank. And we may have plus or minus some numerical terms. And we have a coefficient in front of the x. All right? That something of this form will be called a linear expression. So here we have a pair of linear expressions, 4x plus 1 and 2x plus 7, separated by an equal sign, so that makes this a linear equation. Now what we want to do is solve this equation. We want to find the numerical value of x so that if we were to substitute it in these expressions, it would make this equality a true statement. So how do we find that? Well, one useful way to think about equations is to think about a scale, and that's what we have pictured down here. We have a scale. And you'll see that if I place some weights onto this scale, the scale will be tipped out of balance. Now, for the equation to be true, this scale needs to be balanced. That's what the equal sign means. It means that the weight on the left-hand side is equal to the weight on the right-hand side. All right, so what I'm going to do is I'm going to load up this scale so that it matches the equation that we see here. So for instance, we see 4 x's on the left. So I've already got 1. I'm just going to add x's here until I have 4. And then I have plus 1. All right, so I'm going to put a 1 there. On the right-hand side, I have 2 x's and 7 1's. And when I place the last one, you'll see it makes the scale balance. The reason the scale balances is because of this equal sign. We are told that this weight equals this weight, so that makes the scale balance. Now, how do we solve this problem? Just think about what you would do in real life if someone gave you this scale and these blocks. How would you determine the value of x? How much does x weigh? Well, one thing we can do is we can start removing things from the scale. And the scale will remain balanced provided we remove the same amount from each side. So that's what we're going to do. We're going to remove the same amount from each side. So for instance, I can remove 2 x's from each side of this scale. I can take an x off of the left-hand side. I can do that twice, so I took 2 x's away. And if I take 2 x's away from the right-hand side, the scale will remain balanced. I took the same amount of weight away from both sides, so the scale remains balanced. Now, I can't continue doing this because I have no more x's remaining on the right-hand side. But I can start removing 1's, right? So I can remove a 1 from both sides. And if I do that, the scale remains balanced. Now what can I do? Well, I don't have x's on both sides. I only have them on one side. But what I can do is realize that, well, I can take half of the amount away from each side. And if I do that, I'll be left with a single x on the left. So let's take half of the x's away from the left-hand side. So that's half of them. And I'll take half of the 1's away. So I have 6 1's, so that means I'm taking away half of them. That's 3. And the scale is balanced because I took the same amount away from each side. And now we see what the value of x is. We see that a single x weighs 3. So x equals 3 is the solution to this equation. This is how we are going to use algebra to solve equations. So if you think about what we did, we were making adjustments to the sides of the scale, and we can do that provided we do the same thing to both sides. So that's how we're going to handle equations. We can perform an operation to an equation provided we do the same thing to both sides of the equal sign. So let's go through this exact same problem, but do it algebraically instead of looking at the scale. Okay, so here's my equation, right? What was the first thing we did? Well, we removed 2 x's from each side of the scale. So that's subtracting 2x from each side of the equation. Now when I do that, 4x minus 2x, well, I'm left with 2x. And 2x minus 2x, I'm left with no x's, so I don't write any x's there at all. The 7 just comes down. Then what was the next thing we did? We removed 1 from each side. That means we subtract 1 from both sides of this equation. Now notice the 1's and the x's are distinct quantities. These cannot be combined or merged in any way. I have to keep them separate. But if I do have 1 here, I can subtract that 1, and that leaves me with no 1's. So on the left-hand side, I only have 2x. On the right-hand side, I have 7 1's minus 1 1, which leaves me with 6 1's. Finally, what was the last thing we did here? The last thing we did was we took half of each side. So I divided each side by 2. If I have 2 x's and I divide by 2, I'm left with a single x. If I have 6 1's and I take half of that, I'm left with 3 1's. And so here I have solved the equation. So we did the same thing that we would do in real life with a scale, completely algebraically, and we see it works. It gives us the answer, the solution to the equation. Now, what does that mean to be a solution? That means that if I were to take this number and plug it back in for x up here, it would make this equation true. Let's check it. So to check it, I'm going to replace the x's with the value that I got. I'm using parentheses so it doesn't look like 43. I can see it's 4 times 3. And it doesn't look like 23. It looks like 2 times 3, which is what it actually is. Now, I'm not sure if this is actually true, right? I'm checking it. So let's simplify the left-hand side and just see. 4 times 3 is 12. Is that the same as 2 times 3 plus 7? Well, let's see. 12 plus 1 is 13. Is that the same as 6 plus 7? Well, yes, they're the same on both sides, so it checks out. This is how you check your solution. You plug the number you got back in for x, and you make sure that when you simplify each side, you get the same value. So we've solved the equation, and we've checked it, so we're sure that it's right. Great. Let's go through another one. Now, in this one, you'll see we have negatives and a minus sign. How can you view this in terms of a scale? Well, you could imagine this as attaching helium balloons to the scale that actually lift upwards with an amount of weight corresponding to the value. So -2 would be like attaching 2 helium balloons, each of which lift upwards on the scale with 1 pound. So 1 pound is 2 pounds upwards. So it still works. Negative signs are lifting up, plus signs are pushing down on the scale. Now, how would we solve this equation? Well, I still want to get x's all on one side of the scale, right? So I don't want them on both sides of the scale. So what I'll do is I'll do something to both sides of the scale so that all the x's end up on the left. Well, I want to get rid of them on the right. Well, if I have -2 x's, what I can do is add 2 x's, and I have to do that to both sides of the equation. X plus 2x, 1x plus 2 more x's makes 3 x's. -2 x's plus 2 x's, they cancel each other out. So I have no x's left, plus 7. Now I need to get rid of this -2. I want x to be alone on the left-hand side. So I want this -2 away from here. So what I'll do is I'll do the opposite. I'll add 2. But if I do something to one side of the equal sign, I have to do the same thing to the other side to keep that scale balanced. So I add 2 to both sides. Now remember, you can't combine these. These are x's. We're saying there's 3 x's and there's 2 1's. X's and 1's can't be combined. It's like apples and oranges. You can't combine them. So we keep those separate. But what I can combine are these. Right? So -2 plus 2 cancel each other out. So that means that I just have on the left-hand side 3x. On the right-hand side, I have 7 1's plus 2 more 1's makes 9 1's. Okay, so finally, I want x to be all by itself. I do not want this 3 here. How do I get rid of the 3? Well, if I have 3 of something, I just take 1/3 of it to get 1 of that thing. So I'll divide both sides by 3. 3x's divided by 3, or 1/3 of 3x's, is just a single x. In other words, the 3's cancel. 9 divided by 3 is 3. And so we see once again the solution is x equals 3. That's a coincidence. I didn't realize it was going to come up to the same solution as the last problem. That's completely coincidental. But yeah, so it looks like the solution is x equals 3. Let's check our work. How do we check it? Well, we take this number and we plug it in place of the x up there. Notice I put parentheses here because I'm multiplying. I don't need to put parentheses around the 3 here because it's unambiguous what's going on. Okay, so I want to see, is that true? Well, 3 minus 2, well, that's equal to 1. Is that the same as this side? Well, let's simplify this side and see what we get. Negative 2 times 3 is negative 6. Nothing I can do with the left-hand side. It's done. But let's see, I can combine these. Well, I have negative 6 plus 7. I'm $6 in debt. Somebody gives me $7. So now I have a surplus of $1. And that works. The left-hand side is equal to the right-hand side, so it checks out. So we are confident that this is indeed the solution to this problem. Okay, so I was checking the weather today, and today it's a cool 42 degrees Fahrenheit. I've got this set to Fahrenheit. So what if we were talking to our friend who lives in Europe or Canada where they use Celsius, and we wanted to convey to that person what the temperature is in units they would understand, in Celsius degrees? How would we do that? Well, fortunately, we have an equation that allows us to convert between Celsius and Fahrenheit. The equation is this. F equals 9/5 C plus 32. This is the equation that relates Fahrenheit to Celsius. Now, if I want to convert from this temperature here for Fahrenheit, I'll just plug that in place of F. Okay, now what do I want to do? I want to find what the Celsius temperature is. I want to solve this for C. So let's use our method of algebraic manipulation to solve this equation. What we were doing is we were performing operations so that we'd get the variable isolated on one side of the equal sign. So for instance, I don't want this plus 32 over here. I want C to be alone, right? So I'll subtract 32 from both sides. Now, if I do that, what do I get? Well, on the left, 42 minus 32 is just 10. On the right, I have 9/5 C plus 32 minus 32. Those cancel each other out, so I just have this. Okay, let's take that over here. Now I want to get rid of this fraction over here. Well, if you want to get rid of a fraction, one thing you can do is to multiply by the denominator, right? So I'm going to multiply both sides by 5. If I divide by 5 and multiply by 5, nothing happens, right? So those cancel each other out. On the left-hand side, I have 5 times 10, that's 50. Now I want C by itself, so I want to get rid of the 9. If I'm multiplying by 9, to get rid of the 9, I'll divide by 9. And I do that to both sides. That cancels the 9's over here. And so C equals 50 divided by 9. That is an answer to our problem. You might want to represent this as a decimal if your friend wants to get a decimal answer. And if you compute that out, you'd see that C was equal to approximately 5.56. I'm rounding to the 100th place. And so this is the temperature in Celsius today. Pretty cool. Pretty close to 0, actually, 0 being freezing. So not too happy about that. So in other words, 42 degrees Fahrenheit corresponds to 5.56 Celsius. And we can actually check that here on the Google weather here. If I click C, you'll see it rounds it up to the nearest whole number. They actually rounded it to 6. But that is, we actually have a more precise answer right here. Okay, so that was solving linear equations. Just some important things to remember. When you're doing this, you're trying to get the variable all by itself on one side of the equal sign. And you're doing this by performing the same algebraic operation, adding something, subtracting something, multiplying by something, dividing by something, on both sides of the equal sign. As long as you do the same thing to both sides of the equal sign, the equation will remain an equivalent equation, and you can work your way down to the solution, x equals, or whatever the variable is, c equals in the case of our second example. So hope you found that useful. I'll catch you in the next video.